In this video, we are going to discuss conic sections and specifically ellipses, how to write the equation and graph an ellipse. By definition, an ellipse is a set of points created such that if you were to take the distances from two fixed points, for example, this F1 and F2 being the two fixed points, and if you were to take the distances to some point, that it would actually give you the same distance. Meaning, let's say if I was to add up this first distance and this second distance and it equaled 16. So if I was to take another point and I drew a line and found the distance from a fixed point to this, along with the distance from a fixed point to this, they would also add up to 16. If I was to take another point and I was to add up the distance from this fixed point and then from this fixed point, they would also equal 16. Same thing down here. If I was to take the distance from the fixed point to this point and then this fixed point to this point, it would also give you 16. Doesn't matter what the number is, but whatever it's going to be, it's always going to add to some constant. There are two directions for ellipses. You could have a horizontal direction and you could have a vertical direction. But again, P representing some point, you have an F1 and F2, which are fixed points. And if you were to draw lines, straight lines to that point, if you were to add up this distance plus this distance, it would equal if you were to do it around any other point as well. Now there is some vocabulary here for an ellipse. So you have two axes. You have a major axis and a minor axis. If it's horizontal, the major axis is going to be along the x-axis. The minor axis would be the y. Major and the minor. The vertex is the end point of the major axis. The co-vertex is the end point of the minor axis. You also would possibly have the center being 0, 0, unless the center could be moved in somewhere else on the coordinate plane. The two fixed points are what you would call foci, which is the plural form of the focus of an ellipse. If it is a vertical ellipse, then the major axis would go along the y-axis and the minor axis would go along the x-axis. The major axis is always the longer distance from the center to the vertex. So the co-vertex in this case would be along the minor axis. The foci, you're still going to have a focus of F1 and another focus of F2. If you have a horizontal ellipse, this is the equation of an ellipse. It is x squared plus y squared all over A and B. And if you remember, A represented the vertex along the major axis. Here, if you look at the vertex along the major axis. So, one thing you'll notice is that you always start with x squared. It always goes from x squared plus y squared. But what changes is what would be the denominator. Also, one other thing to notice is it's always equal to 1. An ellipse is always equal to 1. The vertices would be represented by A of 0 and negative A of 0 because it's along the major horizontal axis. So that's why you're dealing with the x-axis or the x value. The co-vertices is going along the minor axis, which is in this case the vertical axis, which deals with the y values. And B is underneath the y value of the equation. One thing later we're going to discuss when we're dealing with the foci, they represent that by C, and this is how you will find C. If the ellipse is vertical, and if you notice, again, it does start with x squared first. You always go x squared to y squared. Also, it's always equal to 1. But one thing I want you to notice is that B is going first. Remember, A is dealing with the vertice. And if A is along the vertical axis, then A is going to be underneath the Y value. So if it's a vertical ellipse where A is going to be a bigger number, then it's going to go under the Y. And if it's a horizontal, A would go under the X. So let's try an equation. We want the equation of an ellipse that has a vertex at 0, 4 and a co-vertex at 3, 0, and is centered around the origin. So let's draw this. So a vertex, all right, first a center around the origin. A vertex is 0, 4, which means the other vertex is going to be 0, negative 4. A co-vertex is 3, 0, which means the other co-vertex is going to be negative 3, 0. And I can now graph what I think the ellipse will sort of look like. So the vertex is bigger. That's represented by A. And it is along the y-axis. So therefore, I know it's going to be x squared plus y squared equals 1. My vertex is along the y-axis, so I'm going to put it underneath my y value. My co-vertex is along the minor axis is along the horizontal, the x values, so it's going to go under the x value. So therefore, you can either write it like that or go ahead and actually square them. 3 squared is 9, 4 squared is 16, and that equals 1. Remember, the bigger value is going to go by A, and it's underneath the y because the bigger value is along the y-axis, or the vertical axis in this case. There is an ellipse that is 20 feet wide and 13 feet high. So if I was to draw, that means I have an ellipse. If it is 20 feet wide, that means from the center, it is going to go 10. And if it is 13 feet high, then from the center, it's going to go 6.5. So now I can write my equation. This is a horizontal ellipse. So therefore, my vertex is going to be 10 squared. And it's going to go under the x because it's along the x axis. And then the distance from the center to the co-vertex is going to go under my y, which is 6.5 squared. So you can either leave it like this, or you can go ahead and write out the fact that 10 squared is 100, and the fact that y squared is 42.25. And again, it's always going to be equal to 1. Now, what happens if the ellipse is not on the origin? So in this case, it looks like this ellipse is about right there, which is at -2, 3. So to find the distance along the co-vertice and the vertice might be a little bit tougher. And here are the equations. HK, if you remember that from the equation of a parabola, the H represents your X and the K represents your Y value of the center. HK represents the center, your X value and your Y value of the center. If it's horizontal, then A is underneath the X value. And if it's vertical, then A is underneath the Y value. So for example, in this case, X plus 2, since the original equation is an X minus H, the fact that this is an X plus 2 means you actually had to go to the left 2 and then Y minus 3. So therefore, I know that my center is going to be the opposite sign. X plus 2 means you're going to have a -2, and Y minus 3 means it's going to be a 3. Because the original function have minuses, then you're taking the opposite. So -2, 3 is going to be right here. The distance from the center to the vertex is 1, 2, 3, 4, 5. And that is why you would get 25, because that is 5 squared. And you went horizontally, so that's why you had it under the X. The vertical distance from the center to a co-vertice is 3. And that's how you get 9, because 3 squared is 9. For the vertical ellipse, again, you went left 2 and up 3. The vertex or the vertice is now vertical, and the distance is 5. And so that is where you get 25, which is 5 squared. But again, if you notice, it is under the Y value because it is vertical. And then your X value is going to be 3, which goes underneath your X because you went horizontally for that. So now let's try a problem. We have co-vertices at 4, 2, which would be here, and 0, 2, which would be here. The vertices will be at 2, 7, and then 2, -3. So my ellipse is going to look like this. Because my ellipse is vertical, it is stretched vertically, then I know it is going to be x squared plus y squared equals 1. And the A is going to go under the y, and the B is going to go under the x. That means if I was to draw a line connecting my vertice, and I was to draw a line connecting my co-vertice, where they overlap is where I'm going to be able to find my center. So therefore, my center is going to be at 2, 2. So my center, which is HK, is going to be at 2, 2. So therefore, I know that it is going to be x minus 2 squared, y minus 2 squared, because remember, the original formula is a minus. Now, we know that A needs to go under the y. So the distance from the vertex to the center from 2 to 7 is 5. And I know that my distance from the co-vertice to my center is 2. And then you square it. So therefore, our final answer is going to be x minus 2 squared over 4 plus y minus 2 squared over 25 equals 1. In this practice, we're going to determine the vertices, co-vertices, center, foci, and direction. So I'm first going to look in the numerators. There is no x minus a number, or there is no y minus a number. And so therefore, we know that the center is at 0, 0. We also know, based off of the higher number, we know that it is going to be a vertical ellipse, and we are looking for a squared is 49, so therefore we know that a is 7. So we know, therefore in that case, our vertices, because this is a vertical ellipse, our vertices are going to be 0, 7 and 0, negative 7. Again, since this is a vertical ellipse, then the a is going to represent the y value. Therefore, I know that 16 must represent b squared, which means b must be 4. So the co-vertices must be along the x-axis. So it'd be 4, 0, and negative 4, 0. So we know 1, the direction, it's a vertical ellipse. We also know our vertices, and we know our co-vertices, and we know our center. Now in this case, our problem is the fact that this is not equal to 1. So the first thing you have to do is you're going to have to divide by 225 in order to get the number 1. 9 divided by 225 is going to be 1 over 25. And 25 divided by 225 is going to be 1 over 9. And so now we have written the equation. We could even go further in this, stating the fact that the higher number is always a, which means the 9 is b. So I know since the a is underneath the x, I could say that this is going to be a horizontal direction, which means that I know that if a is 5, because a squared is 25, then I know that the vertices are going to be 5, 0 and negative 5, 0, because this is a horizontal direction. It's under the x-axis. I mean, it's along the x-axis, so that is why the x values change. B is going to be 3 because b squared is 9. So the co-vertices would be 0, 3. It's along the y-axis. And 0, negative 3. So bonus round. What we're asking is to write an equation in standard form. In order to do this by hand, you're going to have to know something called completing the square. So here's what I'm going to do. I am going to pull my x's together. Then I'm going to pull my y's together. And then I am going to add 19 to the other side. So this is all of my x values. These are my y values. And then all my constants are going to go on the other side. So I need to complete this square for my x and for my y. Here's how you do it. You're going to take your, what we call the middle number, which is 6. We are going to take half and then square it. if I was to do that, I'm going to write it. I'm going to write it again. If I was to do that, take half of 6, which is 3, and then square it. 3 squared is 9. And whatever I do, that I'm adding 9 here, I have to add 9 to the other side. Now I'm going to do something with the y's. I'm going to pull out a 2. If I do, then 2 times 4 is how I get 8. So if I'm factoring a 2 out of all of my y values, then 2 times 4 is how I get 8. So I'm going to do it again. I'm going to take 4, I'm going to take half, which is 2, and I'm square it. And if I square it, I get 4. Now, I'm actually not going to add 4 to the right because you got to remember, I had multiplied everything by 2. So I actually have to add 8 to the right-hand side because 2 times 4 is 8 on the left. So I had to add 8 on the right. Here's why. If I was to then factor this equation, I would actually get x plus 3 times x plus 3 because 3 plus 3 is 6 and 3 times 3 is 9. X plus 3 times x plus 3 is x plus 3 squared. If I was to do the same thing, if I was to factor, therefore I would get y minus 2 times y minus 2 because negative 2 and negative 2 give you negative 4, but when you multiply you get a positive 4. And a y minus 2 times y minus 2 is the same thing as y minus 2 squared equals 36. Now, all ellipses have to be equal to 1. So therefore, I am now going to divide everything by 36 in order for it to be equal to 1. And my final answer would be x plus 3 squared all over 36 plus y minus 2 squared over 18 because 2 divided by 36 is 18 equal 1. And that is now in standard form.